Hi. First, the RxJS stuff with Qwik, that's coming along. I've been a little distracted. I'll talk about that later. But yeah, I think I'm on the right track. So I'll post that as soon as I can. I'm not going to wait for Monday or anything like that. If I'm ready over the weekend, I'm going to post it. I'm not really interested in like trying to hyper optimize for the optimal published time for views or anything like that. I don't really care. But yeah, that's coming soon. But today I wanted to share some thoughts about an interview that Steve from BuilderIO did with David K. I don't know what K stands for, but he created XState. So they had a really interesting conversation. So I'm going to share some thoughts I had about that. The first part is visual programming. It's something I used to care a lot about. Not so much recently, but visual programming, WYSIWYG, that kind of thing. Second is state machines. And then third is kind of general stuff about reactivity they talked about. It was a great video. I'll have a link in the description. Go listen to it. But all right, so and then finally I'll give like an update, a little more specific update about what I've been doing and my general plans going forward. Another update, I guess. That was the last video too. But anyway. So visual programming. That was a really interesting interview. You should go watch it. I used to really care about visual programming. I thought that in the future we'd all be wearing like HoloLens or something like that. We'd be like, walking around in a park while coding with these like holograms, and we'd be like super futuristic looking with these things on our faces, and yeah, I thought that was the future of programming, and maybe it still is actually, someday maybe. But so that was along with state adapt. That was one of the things on my list of things to look into once I got some free time and quit my job and just decide to focus 100% on state adapt and open source and all these ideas I've been having. So that was one of the first things I looked at because I thought I could, kill two birds with one stone. I could make some documentation for state adapt and maybe like an example app and like do some visual programming thing. Basically code the visual editor in state adapt as a demo for state adapt. So I thought that would be a great idea. And so I started really looking into the visual programming stuff. And once you look into the details, it's not what it seems. It's not the magical silver bullet that I thought it would be. It turns out code is actually very great. The like text itself. So this is my first time using Excalidraw. Everyone's using it, so I got to try it. So let me show you what I'm doing here. Here we go. This is visual programming. You have two things and an arrow connecting them. Okay, what does this mean? Honestly, like these nodes or whatever, they can represent anything. And the arrow, it can represent anything as well. It's pointing to another thing though. So in code, that's basically a variable referring to another variable. See, I thought the RxJS and streams were a perfect example where this visual programming would work. This is because I came from a physics world where we use LabVIEW. I usually say I started programming in 2013, but really kind of 2012 maybe, if you count this. This is LabVIEW, and it's, let me try to find, let's zoom in. Okay. You can't really see that too well. That's just not a very big picture image. So, here's, well, that's not a good example either. Here we go. Is this full screen? No, that's Google Lens. That is pointless. How do I'm just going to open a new tab. Oh, okay. Oh, come on. There we go. God, that took forever. All right, so this is called a block level diagram. So it's visual programming, and it gives you a control panel. So you create a control panel. It's usually like your sources. This is where this is part of the thing that influenced my sources versus sinks terminology in my ngconf talk in 2019. But I also got that from Andre Staltz as well. But Andre Staltz has like a visual debug tool for RxJS. So this was very much in my mind, all these things that they're connected somehow. And I think that it does actually, like, reactive programming does lend itself to, like, it just seems right using wires with things flowing through them. So basically on the left, you create these variables, and these are controls in the UI. And so when you run the program, you get that UI, that user interface, and let's see if you can get one of these like ugly things. If you can see one of these, although I searched block diagram, if I just do lab view, no thanks, lab view, you can see what the actual user interface. Yeah, look at this. Isn't this great? Doesn't it look like you're a physicist when you're looking at something like this? Yeah, current temperature. Yeah, I remember I created a thing where it would display. It doesn't matter. It was a fun project that we did in a physics lab. Anyway, so yeah, so you're using these controls. Basically, there are two editing sides to it. One is user interface, and you have these that are available, and you can decide what controls they get. I think they get default options with, like, depending if it's a Boolean or numbers, things like that. And then you can drag it where you want in the user interface. And then over in the block level diagram, the block diagram, this is where the actual logic happens. And then on the right side, you end up with output variables that you also get to specify in the UI. And I really like this. This is reactive programming. But there's a reason this hasn't taken over, because stuff like this. Let's see, where there's like a while loop. Like, they just get really low level with their visual programming stuff. And it is honestly inconvenient to control a while loop visually. It really sucks. I'm not a LabVIEW expert. I only took a couple classes where I used it. 2 or 3 probably. So I'm not an expert, but just, it was confusing understanding it. And plus these diagrams, they just get massive. So there are a few problems that it had. One is like code organization and creating abstractions. That was annoying. It should be really easy to create components and use things. And you can do that with this, but it's like old technology. Like, you have to open a new window on your computer for a new file, or for like a block. And I believe you had to choose an icon for it as well. So I don't know, just the flow of like clean code of like abstracting, encapsulating, things like that, and dealing with the little details of like for loops and stuff like that really wasn't great. So what I loved a lot about what David said in the YouTube video, the interview with Steve, was that like the visual programming stuff is high level, and that's where it should be. But I still am I don't think it's quite the silver bullet that I used to think it was. So back to my Excalidraw example. Because if you have a connection between two things, it's neat. It's like there's data flowing there, but at the same time, it's just a reference. It's just a visual reference. When you have let me see if I can find. Yeah, real world example. This is a good one. Well, this is an effects file. This was And I think this is old, but it doesn't matter. This right here, it's referencing something, and that, comes from, where does that come from? Where are you? Down here. Okay. So let's just imagine an arrow drawn from here all the way down to here. And imagine this is visual programming. That actually isn't that interesting. If you want to see what this is coming from, I mean, it has a name, and that's pretty good already. You know what it is, and that's kind of better than an arrow. You just read it and understand what it is immediately. It's right here. But you click on it, and you can see what it's referring to. So that's just like with your eyes. Oh, I just realized that wasn't zoomed in. Sorry. With your eyes, it's just like tracing the arrow and be like, where is this? Oh, that's arrows or actions. So it's not, it's just references. That's all the connections are, just references. However, just like you have, like I was talking about, I think in the last video, like the symmetry between imperative and reactive. You have imperative on one side where you're updating things in a callback, and you have reactive where you're referring to streams and combining them. It's symmetrical, but one is where you have everything that happens at the same time. That's the imperative side. And then everything that has to do with state is on the other side. That's declarative. That's reactive. So what are you concerned with? Most of the time, you should be concerned with the feature itself and not an instant in time. However, with debug tools, well, like when you're debugging, you are interested in what happens at a certain time sometimes. And that's where debug tools like Redux DevTools comes in. But visual programming might also be helpful with that. Oops, what did I just do? Whatever. All right, check this out. So here are connections. This is like a callback function, and it's updating these things. All right. That's one way to see it. Let me draw the arrows the other way. Okay, here's the alternative. You have a feature that is referring to events or streams and combining them into a thing. So these are symmetrical, and it's not actually perfectly symmetrical. I think it'd be fun to do a YouTube video where I show why reactive programming can do things that imperative programming can't do. But anyway, for now, there's this symmetry here. And if you're just using text as code, you're going to see the references when you look at the actual feature. So back here, let me zoom in a ridiculous amount like I did in the last video, because I watched that on my phone later and I actually really liked that. So we're going to do ridiculous zoom from now on. So all of these things that it's referring to, you see these in line right here where this is defined. So that is like over here, you're looking at this circle and you see these connections, okay? So the pro for that is of text is the names, either in line, so you can get the significance immediately. But the benefit of visual coding is that you can see both sides of this. You have your code that is organized by feature and by the time of execution of code. So a callback function, you can actually trace it either way. Here, you can immediately see that it's pointing to these things, and maybe it'd be nice to be able to have maybe a small screenshot of the code in here, like text code in here, and you just see where it's pointing to, and then you double click on this and it zooms in and you get like text that you can edit. That'd be nice. And you know, David was talking about like these like little black boxes that you edit with your code, and that's good. That's what I'm thinking. With like the low level operations, you do want code, and then the overall thing could be this visual stuff. But then like you also get to see when you're here, you get to see all the things that happen downstream. So you kind of get both. You get code that's both organized by when it executes and what it defines. So you kind of get both of both wait, the best of both worlds. That's what I was trying to say. So, yes, this actually would be great. And he mentioned that there's a VS. Man, I can't wait to try out XState. I can't wait to try it out and really dive into it. Because he said there's a VS Code extension that adds visual elements in. And what I've been thinking of for a long time is focus on the text first, the code itself, and add visualizations on top of it that are very minimal, that are two-way, like he talks about. You can edit the diagram and it edits the text, or you can edit the text and then the diagram will update. But it's very thin and it's very high level at first. That is what I think visual programming has to offer. And I think it is actually very interesting. It's just the tooling around it is going to be really difficult. But they talked about this in the video, that finally with declarative code, you can do visual programming with declarative code much more easily than imperative code. I think that's why LabVIEW is visual, because once you define sources like this and you're not constantly updating that, like it's not imperative, things are declarative, you can actually have a symbol for something and things that connect into it, and it actually makes more sense. I could be wrong, but and they could be wrong, I guess, if I'm wrong, but I do think that they're right about declarative code being easier to create tooling for. Because here's the thing, if you have a balance between declarative and imperative, which is what almost every single app is right now, it's a balance between imperative and declarative. There are so many ways to organize your code between those different styles. With declarative code, there's only one way to organize it. You can split things up, but those things, whatever entities you have, whatever pieces of state, whatever things in the UI, there is one way to have those defined. With imperative, you can update things from a number of places. You can abstract into utility functions or second order functions, update a bunch of other things. But like if you go 100% imperative, which I don't even know if it's possible, and then 100% declarative, either of those are kind of deterministic. They kind of declare, they kind of set in stone, like they define your code structure itself. Because declarative code is a code structure. A thing defines itself. Like how many ways can you organize your code if everything is completely self-contained? There's basically only one way to do it, and you can split things off, like I was saying, like different entities that react. Like with RxJS, you can have like 5 redundant streams in between that all just have a tap or a map operator, whatever, or a tap console log, whatever. But really, like the significant thing is there's only one place to put it. So I think maybe that's why visual programming might be easier with declarative code. I think that's probably it. But anyway, so they said something. David said, he's talking about jQuery, the jQuery days, where you're like imperatively updating things. You have like a list, and you're adding list items, and you're editing things like all in like callback functions. And then we get like the framework, the age of frameworks like Angular and so on, where you could have declarative DOMs finally. Like the DOM code is declarative now. That is it. What he said was that process is what we're starting to see with state. Well, the entire application code, like all of it, the entire application code base. It's what happened from jQuery to Angular is what's going to happen right now for state management. I have things to say about XState, but basically, yeah, that I agree with that. That is what. Yeah, so I said at the end of my talk at NGConf in 2019 that basically Angular brought reactivity to the DOM. Redux kind of brought it to state management, and David kind of said that too. I think somewhat. I don't remember exactly what he said. RxJS brings it to the entire app. That's why I like RxJS. But it's thinking reactively. It doesn't matter. Like I've explored these different alternatives with RxJS or hooks. In the end, they make your code structured the same. And they're actually very similar underneath. They're just functions. So this is, to me, this is like 100% certain that declarative code is the future. And yeah, it's going to be more and more popular. It's going to gain more and more momentum. And then the tooling around it, like I believe there is tooling that is only possible with declarative code, just like they're saying. So with that, all that, that's like in general what I wanted to say about that video, about that interview. Now I'd like to get into a little more specifics. So one of them said, I think Steve said that SolidJS has reactivity. And I still, this is why I made the video, the why RxJS compatibility matters, when I wrote that article as well, because I do feel like there's a belief that synchronization is what matters with reactivity, and like that's it. And it's the way Ryan Carniato talks about it, and I feel like everybody who isn't really aware of RxJS or hasn't really used it, the way they talk about it is like, we got reactivity. SolidJS is actually reactive. Svelte is reactive, and it really really bugs me because it's not solid. Like, and then like there, I feel like there's like an insistence when I bring this up with people that there is like, well, okay, maybe RxJS is more reactive, but when are you ever going to use that? But synchronization, that's the real important reactivity. Like, who cares about the other reactivity? But no, like the exact benefit you get from synchronous reactivity is the exact benefit you get from asynchronous reactivity. You can't separate them. You can't say that synchronous reactivity is important, but async isn't. You get the exact same benefit with both of them. So I really don't like that. So that weird emphasis on the synchronous reactivity, but it just comes from the fact that it's easy to implement and it's the most common kind. So no, SolidJS doesn't have reactivity. It doesn't. SolidJS does not have reactivity. It has some reactivity. It's able to do synchronous reactivity, and that's very easy. I don't know why frameworks haven't had this like 10 years ago, 5 years ago. I don't know, whatever. This should have been, I feel like this should have been mainstream like a long time ago. I think the first version of Vue kind of did a little bit of that with proxy. Not proxy. They had some other thing. But anyway, I agree with Ryan that knockout that should have been. I didn't know about it at the time, but listening to how he talks about it, yeah, that like I don't know why people moved away from that exactly, but yeah, that's its own topic. But yeah. It's such a basic thing, synchronous reactivity. Obviously, it should be in frameworks. Obviously, it should be in frameworks. And it really bugs me that it's not really. But at the same time, async reactivity is just as important. So SolidJS does not have that. It has the building blocks to create it, but it doesn't have async reactivity. You have to do a lot in order to get it in Solid. So use RxJS until a bunch of custom hooks come along with signals, and then you can have async reactivity in like a solid native kind of way, whatever that means. But yeah, Solid is not reactive. It's partially reactive. Same with Svelte. React is barely reactive with the DOM. So it's, yeah. Anyway. And okay. David said that effects should be close to event sources. And this is a little contradictory. it's because it's not reactive. So let's see. I don't know if I can use this to illustrate it. No, I can't. Not really. Maybe this. Maybe we can draw what I'm talking about. I'll just explain it. Whatever. Effects, like the entire DOM is a side effect. Why you don't want it close to the event, because that's imperative. If it's in a callback function, like a click handler, yeah, he actually said click handler or handlers. So event handlers. If effects should be close to events, which means they should be in event handlers. Actually, callback functions are containers for imperative code. Everything you put in a callback function is imperative. So if you want declarative code, you don't want effects to be in callbacks. Okay. So it's a very simplistic rule to just minimize callbacks, but it works. That is the way you code reactively. Don't write callback functions. So yeah, so I disagreed with that. He said a good thing about simple versus complex. If you can update state directly, things become complex later. So at 54.5 minutes in the interview, he gave a counterexample with a counter. So if you have a counter and then you want to impose limits on it, like a maximum or minimum, then where do you put that logic? So if you have it in a callback function where it's state, counter dot or counter plus plus, where do you put the limit logic? And then like all these rules, they end up like scattered among callback functions, and this is the problem. You end up creating reducers that are scattered instead of centralized good ones that are self-contained and relevant. So it's just a crappy reducer is what he called it, I think. Maybe that was my own term. So that's why we like reducers, and what it does is it allows. So it's really easy to add a line of code to a callback function, but it creates this MVC jungle of everything's updating everything. And then how do I know why this feature is the way it is? Well, you have to go find a thing that updated it. It's not declarative, and it scatters logic across your code, callback functions. So that is why Redux makes things simpler, not necessarily easier. Okay, and then this is relevant to the next point, 56.5 minutes. Examples will not be favorable to XState. So they mentioned that XState always requires like a certain amount of boilerplate, and so does Redux. Here's the thing. I made a video about this a while back. I don't remember, a couple months ago. Basically, StateAdapt used to have a very strong opinion that your code should be 100% reactive at all times. So, looking at the website, the StateAdapt website, this is so something that bugged me was comparing StateAdapt with other libraries for really simple examples where I'm forcing this structure. If you look at, let's see, sources, where basically you have to create a source in order to do anything. Where let me find a good example. Hang on. Here we go. New source. Right. So you have to do, well, this is an example of what not to do, but in general, in StateAdapt, you have to create new sources, and this used to be the only way you could do things. You couldn't imperatively update state, and this is what David agrees with. This is what how he's designed XState, and then I kind of had a realization. It was the callback thing that callback functions are the problem, because even with a reactive approach, in the template, you're always going to have something here. Like it's going to be like .next on a subject in the case of StateAdapt or a source, or whatever. But you're going to have something here. And so your goal should actually be to push the most minimal amount of state from the DOM, from the event, into the TypeScript code as possible. And so minimize that. And that is the most reactive you can get. And I'm still thinking about this, like exactly what that means, because CycleJS is very, very, it's like the limit of how reactive you can get. But even that, you're defining part of, like you have a hard-coded string where the event source is defined in the TypeScript or JavaScript, and that splits the definition of the button up there and down there. So where you're listening to the click events and down where you're actually declaring what it looks like. So maybe the goal is to minimize what the downstream code has to define of the button, but you still have to have part of it defined in two places. So yeah, I'm still thinking about that, but basically David, I think he has the approach that I used to have, where I was saying absolutely no direct updates to state. That is imperative. It's not good. But after realizing that no matter what, you're going to have something imperative. So to make like the hello world example better, I decided to allow a direct updating of state with this guideline that you don't write callback functions. And it seems like a crazy guideline because everyone writes callback functions, but callback functions are like the fork in the road where you go from making one simple update in the state. And if you're going to allow syntax like this, you have to have a rule like this. But because you have a choice where if you write a callback function, you're making room for more imperative code. And that's where it becomes an imperative style of programming. So I no longer think that you should be like 100% like have sources as these like independent clean things at the very top and then things go downstream from there. I think that you just minimize the imperative code in your app and you're good. It doesn't matter what you do. You just have to minimize it and make your sources extremely simple. If this is all that needs to happen for, when this button's clicked, there's nothing wrong with this at all. And the way I think about it is I call them synthetic sources in the code base of StateAdapt. What happens is it takes the adapter methods and it creates synthetic sources. So basically, you're defining a source still. It's just part of the store. And you don't need it as an independent source until you need multiple stores to react to it. But for now, it's just like syntactic sugar. And that's the thing. It's okay to do this because it's easy to change later. As long as you have that guideline of don't write callback functions, when you have to adapt to higher complexity, it will be easy to split it out into a source and have two things react to it instead of having one callback function that updates two things. So I think this is honestly a bit of clarity that gives StateAdapt an advantage over XState that I hope like I don't have any way of influencing David at all. So I have no idea. I don't really hope anything, but maybe he'll change on that. Maybe he won't. It doesn't matter. I care a lot more about reactivity than this convenient syntax. But anyway, it'll be fun when I get to compare XState with StateAdapt down the road, and I get to like take in some of the cool things from XState and incorporate them into StateAdapt. I talked about in a past video. So yeah, and at it's kind of continuing the same idea. At an hour and 1 minute and 30 seconds, he was talking about starting with a promise or observable and progressively enhance it. This is what I love. this idea that, and SolidJS does this too, where you can start with no assumptions, and then if something more complex needs to happen, you don't need to change the syntax so much. I call that a syntactic dead end, where you commit to something like an Angular pipe, and then you later realize that, oh, we need to actually handle more complexity, and then that thing no longer works, so now you have to delete code and then write different code, where the code you write instead, you could have just written from the beginning. So RxJS, like, you should go to it pretty quickly in Angular. And when they come up with their synchronous reactivity, maybe you go to that first and then RxJS. But the idea is you just don't write callback functions. You minimize the imperative code, and then you go to the thing that can handle the next level of complexity. So just like he's talking about starting with an observable or promise, this is basically an observable, name store.state with stated app. This is like the progressive reactivity in Angular. I wrote the article series in order to come up with syntax for stated app, because I wanted it to be like this, where it's actually, and it came from this realization, this one that I was talking about a minute ago, about sources and synthetic sources, and like, it's actually okay to write imperative code, like if it's extremely simple, because it's not hurting anything. You didn't have to write, let's see, change name, $ equals new source or subject, whatever, and then this dot next Bilbo, and then go to the store and react to that source by setting state. You didn't have to write any of that code. You saved a lot of time by just setting it here. And then as soon as you need more sophistication, you can adapt it very incrementally. So let's say you add selectors for derived state. You can take this exact syntax, put an array around there, comma, curly brace, selectors, and then you define your derived state. And I mean, it's not as convenient as RxJS, but coming with syntax for this was actually kind of hard, where you can define reactions and selectors in the same object. And it's actually pretty important to be able to do this. So it's like a small amount of boilerplate. It's really not a big deal. It's like this is hardly anything. This selectors with another curly brace, that's like almost not even worth being bothered at. So, but that lets you use it here. Okay. So very, very small change to syntax, and you can handle more complexity. And at no point do you have to rewrite anything. If your feature evolves naturally over time, you don't have to kick yourself for not being able to foresee the future. You can just take what you have and adapt it slightly. And I love that XState 5 apparently is starting to use that philosophy a bit. It's pretty great. So, what's this? Oh yeah, I have put green for added code. So let's say you want another type of state change to be able to happen. You just add it to that same object and call it directly. Why not? Call it directly. This is the minimal amount of imperative code you can have still. If you define a source separately, you'd still be calling .next, and that's imperative. So this is fine. And then, and it's actually nice because the name is what it's doing, and there's like a one-to-one relationship, so it's no problem at all to do this. Yeah. I'll do a video on Marco as soon as Marco 5 comes out. Okay, so and then let's say you need 2 of these things. I think state machines, you can like reuse them, which is awesome. That reminds me of state adapters. Like XState and state adapter are pretty similar in a very vague and blurry way. Like if you like squint your eyes, they're kind of similar. But anyway, so just like look at how little you have to do to the code. In the green, it's like over showing. I don't know. It's showing more than what actually changed. All you did was up here, drag, cut, name it. So const, I don't know, name adapter equals paste, And then here you have that slot open. And then you copy and paste this line that doesn't have this object anymore, that's just a closed parenthesis. And then you paste it twice and then refer to name adapter. So very, very, very little work needs to be done. And suddenly you can manage two states independently. So yeah. Yep. Same state logic, different state. This is so annoying to do. And Redux, NGRX, like NGRX component store, I think is a little easier because you can have a base class. It's still not this convenient. Not quite. But okay, so and then like what if you want to have more complexity and more reactivity? Then it's actually pretty easy. Well, this is two things at once. You're adding something a reaction. So this is like logic, kind of it's not part of this level. It's not important. It's just the important thing is what you have to do here. So pass a fourth argument. Oh, I need to update this example. Oh, these are screenshots, aren't they? No, this is text. I need to update this because I got rid of this syntax. You got to have an array around these first three arguments. Anyway, you just add this as the fourth thing or an object where you get to specify what will change because of that source. So like this is the most minimal way you could change this code to express this concept that now the store is going to react to this independent source. Okay. So that's pretty cool. And then yeah, this thing, share DOM event sources with multiple stores. You can have just everything here is like just an incremental change to what was before. But this handles all the complexity I'm aware of with state management, where you have just events happening and things that need to react. So, yeah, I love this. I need to do a lot more videos about this. And that kind of is a smooth transition to the next topic. Okay, so just wrap this up. Yeah, introduce reactivity instead of imperative code. So you have to understand the difference. That's the first thing. Then the second one, this is like the real rule. Don't write callback functions. Those are containers of imperative code. And then you might object to that. You're like, well, what if you need to update local storage? Here's the thing. Wrap imperative APIs with declarative ones. So all this explanation is in that article series. I should link that as well. Progressive reactivity in Angular. And I am just thrilled with this so much. I want SolidJS to have incremental reactivity. It does like already pretty well because derived signals are just function calls too. Qwik doesn't have that as well. I was thinking like this is a potential syntactic dead end for Qwik, where you have a lot of stores and updates, and then you have derived state, and that's like, let's say count. You have count equals Qwik store value double or value 5, whatever, and then you have double equals store dot count times 2. That's like React. When the component renders, it's going to run that code, and your double is going to be updated, and then you render in the template in the JSX. So that's pretty good. But then what if specifically you need something to react asynchronously to double? So you have derived state and then asynchronous reactivity after that, or component inputs. I don't know. But anyway, at least in this case, where synchronous reactivity requires very different syntax from asynchronous reactivity, because with asynchronous reactivity, you have to track a store. You can't track the derived state. You have to track the store itself. And then you can update, set a timeout and do whatever asynchronous reactivity you want to try to implement. But that means that later on you might regret how you implemented something in the simplest way earlier. So, but with SolidJS, your derived state is a function, and when you create an effect or whatever it's called, you can use that derived signal just like you would an original signal. At least I hope you. I assume you can. You'd better be able to. So basically, you're not overcommitting to anything. Like you can change what something is later on, or it's not that you're changing the thing. You're adding behavior, and you're not having to change what it's reacting to in order to add that behavior. So that's really great. And that's like progressive reactivity. But also, SolidJS doesn't have async reactivity like RxJS unless you use RxJS in Solid. So it would be very tempting to add imperative code instead of reactive code in a lot of places, because there's just no way to add the reactive code without implementing a complex, imagine doing like a concat map or something like that with vanilla JS, imperative JS. So that is a drawback. But I hope that like, I think these like the 7 levels of reactivity I talked about, that I didn't really show here because it's like, it's kind of extra and it's a little complicated. I mean, it's not that extra with syntax. Like you just add a store that combines these stores. It's not interesting. That's the thing. It's not interesting. You just assume you should have it because selecting from multiple stores, that's kind of important. And you don't even need any special syntax. You could do a combine latest, even though it would be inefficient unless you use like the Rx Angular scheduler thing. But so, yeah, this I hope that this like example, I want to apply it. I want to write that series, progressive reactivity, for SolidJS and Svelte and React and Qwik. And it's going to take a while to get there, but I'm sick of like worrying about future updates to code, like natural feature evolution, causing me to delete code that I wrote before because it wasn't good enough. That is what good architecture is. When I was new to programming, I thought that the goal of good architecture was to mastermind everything and to be able to see the future. And it's stressful to do that. What actually good architecture is, it's a pattern that permeates your code from the tiniest detail to the big picture stuff, where each individual piece is only concerned with itself and other things can use it or not use it or extend it or whatever. But there's no overreaching, there's no overconfidence, there's no violation of separation of concerns, there's no mixed concerns. It's everything is small, composable, and you can wipe out entire features without affecting the rest of the app at all. Just because everything is declarative, it's self-contained. That is good architecture. So, yeah, this pattern of progressively, incrementally adapting syntax, I love that, and that two things: progressive reactivity and declarative code. Well, progressive syntax and declarative code. So progressive reactivity, that's what it's all about. Progressive reactivity. That is going to define web development over the next 5 years. Progressive reactivity. Incremental reactivity, whatever. It's increasing reactivity. Every time there's an increase in complexity, it's reactive. And so you get incremental reactivity as your app evolves. So yeah, really looking forward to getting StateAdapt out there more and helping other libraries become more reactive and incremental as well. Maybe I should have called this incremental reactivity. I don't know. They mean the same thing. So, how long have I not been showing the screen? Dang it. I just talked about a lot of stuff on the screen. Wow, I hope that wasn't awful. Jeez. Well, just in case. I'm pretty sure maybe you couldn't see this when I was talking. Oh man, this would be terrible. But I'm going to post the video anyway and just go to the StateAdapt website and look at the demos. But you could probably get what I was saying. Incremental updates. And I hope people use this, like examples like this that are as simple as possible, but illustrate the different patterns that can arise. So yeah. Anyway, I want to spread StateAdapt and help other libraries become more incrementally reactive. Gosh, well, let's see how that turned out. But earlier there was a smooth transition that I had, but I forgot it. But I'm just going to talk about the last thing. I've been working on RxJS and Qwik, and I have been a bit distracted from it because some stressful things have been happening in my life financially, because I am all in on Tesla stock, and their Q3 was not amazing, so I don't want to sell anything to support myself financially. So I want to take on a consulting project probably in January, maybe December. And when I do that, I also like to travel a lot. So work from, like New Mexico, California, whatever. So I like traveling a lot. So that's what the future is going to look like. But when I take on that project, progress with this stuff will slow a little bit. But the next thing I wanted to do was apply StateAdapt to a ton of libraries and just do a lot of comparisons. And those are really fun and really easy to do. So those, I can overproduce videos for that and schedule far in advance. So what between January and March will probably look like for this channel is a bunch of scheduled videos where I'm comparing different state management libraries, particularly like StateAdapt and different Angular ones first, and then React, and then Svelte, and then Solid, and then Qwik. I don't think it'll have state management libraries by then, but maybe it will. Actually, yeah, I think maybe David and Steve talked about maybe doing XState and Qwik. But anyway, but between that, so those will kind of be like automated. Those will just publish when they publish, in the first quarter of next year. But I'm also going to be paying attention to updates in Qwik and Solid as they happen, and Marco 5 whenever it gets released. And so I will not have as much time as now to do videos and stuff, but I will hopefully be able to publish still like up to date, not just scheduled things, but like reacting to things, maybe a video per week. But it'll be really fun. I'm really excited. I'm thinking about where I'm going to go. The first part of the year, I'm going to do just a mountain biking trip, St. George, Utah, and then I'm going to go to Palo Alto and visit a friend. And but then next year, I'm thinking of going to more places. I don't think I need to. I think I just need a project for the first couple months of the year. If anyone knows of anything like a fun project that would maybe involve a lot of RxJS or maybe an opportunity to use StateAdapt, that'd be amazing. But hopefully, I actually still want to travel a lot after that. I have plans. I'm going to go to Europe mostly. I want to go to Norway and see the Northern Lights. Hopefully, we're like in a solar cycle, and maybe activity will be peaking next year and the year after, or the year after that. So I don't know. I have a lot of exciting plans that I've been distracted with for the last couple days. So yeah, now that I've kind of figured out what I'm doing with finances and that whole area, I'm like, I have more of my brain available to work on the RxJS and Qwik stuff, because a lot of the work right now is like still kind of high level. Like, how could it work? What about this? What about that? And so like, I'll literally like dream of it and dream about it, and like while I'm showering, I'll think about it. But lately, I've just been thinking about like finances and what to do and what to do at the beginning of next year. Anyway, so those are my plans, and but the RxJS video with Qwik, the last one there, that'll be coming very soon. So yeah, excited to release that finally, and then it'll be state management stuff, state adapt, and yeah, I'm excited. All right, thanks for watching. Thanks for the encouraging comments from on the last video from Brandon Roberts, and what was that other one's name? Hang on, Alexander Kirilov. Thank you very much for those encouraging comments. It got 4 likes. Wow, thanks guys for the encouragement. I'm not gonna stop. This is very important to me. But man, you guys are awesome. So thanks, and yeah, see you hopefully soon with the next video. Bye.